Hello. Hello everyone. Good evening. I think my voice is audible. Right? Okay. So this is lecture number 3 of linear algebra. The playlist of linear algebra, right? UPSC mathematics optional. So if you haven't watched the previous two classes, kindly watch that and come back to this video. This is lecture number 3. In lecture number 1, we have introduced the definition of vector space, and then I have given you 7 examples and 3 problems regarding problems based on vector space. And in lecture number 2, we have introduced subspace, and then we have seen some problems based on subspace, and then we have seen 3 theorems on subspace. That the first theorem is the intersection of any two subspace is a subspace, and the second theorem is the union of two subspace need not be a subspace. It will be a subspace if and only if one is contained in the other. This is what we did in last lecture, right? So in this class I'm going to introduce rank of a matrix, and I'm going to solve a system of equations, non-homogeneous and homogeneous system of linear equations. This is what we're going to do today. This is very important, right? We're going to see linearly dependent, linearly independent, basis, dimension. For all this you have to understand this basic concept, which is rank of a matrix and system of equations. As of now, what we will do is, in this class I will explain how to solve, right? In this class I will be explaining how to solve, how to find rank of a matrix, how to solve system of equations, how to solve a non-homogeneous system of equation, how to solve a homogeneous system of equations. So in this class is purely based on problem solving. In the upcoming classes you come to know why, right? In this class mainly based on how to do, right? How to do, I'll be concentrating this class. Why, right? Why we are using this, that you will come to know in the upcoming classes, right? Okay. So first we'll start with rank of a matrix, right? Okay. So I'll try to complete all three in this next 2 hours. I'll be completing all. Okay, so first is rank of a matrix. So what is rank of a matrix? So rank of a matrix is nothing but number of non-zero rows in the reduced row echelon form, right? Okay, the rank of a matrix. The rank of a matrix. The rank of the matrix is the number of non-zero rows is the number of non-zero rows in the reduced row echelon form. So we have to reduce the matrix to row echelon form. So we have to reduce the given matrix to row echelon form, and then we have to find the number of non-zero rows in that. That will be the rank of A. So denoted by rank of A, right? Row of A. So what I'll be doing is the rank of a matrix is number of non-zero rows in the reduced row echelon form. So when a matrix is said to be in row echelon form, that is the next question for you, right? So we have to reduce the matrix to row echelon form, and in that you find number of non-zero rows, that will be your rank. So how to reduce the matrix to row echelon form when a matrix is said to be in row echelon form. That is what we're going to define. Now I'm not going to write down the definition, right? So I'll take one problem and then I'll explain how to reduce the matrix to row echelon form. So first problem is find the, see, these are 12th standard level concept. Find the rank of a matrix. The matrix is given by the matrix is given by the matrix is given by 1 1 1 3 2 minus 1 3 4 5 minus 7 7 11, right? You always remember the rank of A is always less than or equal to minimum of m comma n. So always you note it down. If A is a m cross n matrix, so m rows, n columns, right? M denotes rows and n denotes columns. So if A is an m cross n matrix, then the rank of that matrix always less than or equal to minimum of m comma n. So whichever is minimum, if the number of rows is minimum or if the number of columns is minimum, you always make sure, always note it down, the rank is always less than or equal to minimum of m comma n. So we need to find the rank of a matrix. So here rank is always less than or how many rows it has? It has 3 rows and it has 4 columns. So the rank will always be less than or equal to 3 because minimum of 3 comma 4 is 3. So rank will always be less than or equal to 3. It can be 1, it can be 2, it can be 3. It will be 0 with 0 matrix, but it is not a 0 matrix. So how to find rank of a matrix, right? So we need to reduce this to row echelon form. So when a matrix is said to be in row echelon form, the first condition is you take the first row, first non-zero element. You take first row, first non-zero element. So what is the first row, first non? See, this is called row 1, this is row 2, this is row 3. This is column 1, column 2, column 3, column 4. So you have 3 rows and 4 columns, right? You have 3 rows and 4 columns. You take the first row, first non-zero element. This is the first row, first non-zero element, right? Just a minute. Yes. So you take the first row, first non-zero element. Below that, everything has to be zero. Below the corresponding column. So you take the first row, first non-zero element. Below the corresponding column, every element has to be zero. But here 2 is not 0, 5 is not 0. So we have to make both the element has to be 0. So what is the first step? That is we are reducing this matrix to row echelon form. So to reduce the matrix to row echelon form, the first step is you take the first row, first non-zero element. Below that corresponding column, every element has to be 0. So you take the first row, first non-zero element. Below that corresponding column, every element has to be 0. But it is not 0 here. So we have to make this 2 as 0 and 5 as 0. Now we have to make these two 0 with the help of the first row, first non-zero element. How we can make this as 0? How we can make this as 0? With the help of 1. So I'm going to use a transformation. The first transformation is given by R2 is transformed to R2 minus 2R1. These are elementary transformations, right? See, we have to make 2 as 0 with the help of 1. So multiply this element with the 2 and then you subtract. You should not do this for single element. You have, if whenever you are multiplying something, you have to multiply throughout this row. So what I'm doing is I'm keeping 2 as it is. I'm multiplying 2 with first row, and if I subtract, R2 is transformed to R2 minus 2R1, then this element will be 0. And similarly, if I make R3 is equal to, I'll keep 5 as it is, and I subtract 5 with R1, then this element will be 0. So after this matrix is reduced to, right? See, I'm using this symbol. This symbol means equivalent. The matrix, both the matrix are not same, but they are equivalent. Equivalent means they share the same properties. That we will come to know in the upcoming classes. So the first row remains at is 1, 1, 1, 3. Right? Now R2 and R3 are changed now. What is R2? R2 is changed to R2, R2 R2 minus 2 times R1. R1 is 1 comma 1 comma 1 comma 3. So what this will be? 2 comma minus 1 comma 3 comma 4 minus 2 comma 2 comma 2 comma 6. So what is 2 minus 2? It is 0. Minus 1 minus 2. So it is minus 3. 3 minus 2, which is 1. 4 minus 6 is minus 2. Is this step is clear? So you can see that we have made the second element 0. Sorry, second row first element 0, right? And similarly, what is R3 is transforming to? R3 is transforming to R3 minus 5R1. So 5 comma minus 1 comma 7 comma 11 minus 5 times R1. So which is 1 comma 1 comma 3. So this will be 5 comma minus 1 comma 7 comma 11 minus 5 comma 5 comma 5 comma 15. So 5 minus 5 is 0. Minus 1 minus 5 is minus 6. 7 minus 5 is 2. 7 minus 5 is 2. 11 minus 15 is minus 4. 11 minus 15 is minus 4. Is it clear? Now the first step is completed. What is the first step in row echelon form? You take the first row, first non-zero element, which is 1 here. Below that, everything has to be 0. Below the corresponding column. So we are done with first step. Now go to second row. Second row, first non-zero element. What is second row, first non-zero element? Second row, first non-zero element is this, right? Below that, everything has to be 0. That is below the corresponding column, every element has to be 0. But here you can see it is minus 6. So we have to make this as 0 with the help of this element only, that non-zero element. Second row, first non-zero element. Now we have to make minus 6 0. We have to make minus 6 0 with the help of this element, right? What we have to do? So I'm going to make an operation. R3 is equal to, see, both are same sign here. So what we'll do is we'll multiply 2 with R2. So it will become minus 6. Both are minus 6. So you subtract. So R3 minus 2 times R2. Is this operation is clear? To make this element 0, what I'm doing is minus 6 minus 2 times minus 3. So they will become minus 6 plus 6. So after this will become 1 1 1 3 0 minus 3 1 minus 2. Now R3 is transformed to R3. So R3 is 0 minus 6 2 minus 4 minus 2 times R2. So R2 is 0 minus 3 1 minus 2. So this will be 0 minus 6 2 minus 4 0 minus 6 2 minus 4. So what does become? 0 minus 0 is 0 minus 6 plus 6 is 0 2 minus 2 is 0. See, our aim is making this element 0. This element 0, I'm not in charge for that. I'm making this element 0. Or in that instance, this turns out to be 0, right? Minus 4 plus 4 is 0. Now, the second step is completed. What is first step? You see, you take the first row, first non-zero element. Below that, everything has to be 0. Done. Then we go to second step. Second row, first non-zero element. Below the corresponding column, every element has to be 0. That is done. Now go to third row. Third row, first non-zero element. There is no any non-zero element here. If there is some non-zero element, below the corresponding column, every element has to be 0. But here, in third row, there is no non-zero element. If there is non-zero element, you have to make that corresponding column, below column has to be 0, but it's not in this case here. So we can stop the iteration. So therefore, this matrix is in row echelon form. This matrix is in row echelon form. This matrix is in row echelon form. So after converting the matrix to row echelon form, what is rank? Rank of A is nothing but total number of non-zero rows. So when a row is 0 row, if all elements are 0, then it is a 0 row. All has to be 0, right? Now this is non-zero row. This is non-zero row. This is a 0 row, right? Suppose if I have 2 here, 0, 0, 0, 2, then it is a non-zero row. Every element has to be 0. So this is matrix row echelon form. This has two non-zero rows, just two non-zero rows. So therefore, rank of the matrix is 2. So when a matrix is said to be in row echelon form, now we will write it down, right? When a matrix is said to be in row echelon form. Row echelon form. What is step 1? First row, first row, first non-zero element below that corresponding below that corresponding column, every element has to be 0. This is the first step, right? Now go to first step. First row, first non-zero element. Below that everything has to be 0, but it's not in this case. So we have made this 0 with the help of first element, right? First row, first non-zero element, everything has to be 0. Below that, below the corresponding element has to be 0. right? Yes. Now step 2. See, you have to make these two elements 0 with the help of this element only. You have to make these two elements 0 with the help of this element only, right? So this element only we have to make that as 0. I'm not writing here. Just understand. Now what is step 2? Go to second row. Go to second row. Find first non-zero element below that corresponding column. Below that corresponding column, every element has to be 0. Right? Now again you can see second row. After this, you have to take this matrix. Second row, first non-zero element is this. Below this, everything has to be 0. Now you have to repeat this process, right? Go to third row. Go to third row and repeat the process. Repeat means if there is a first non-zero element, make below element to be 0. Right? Go to the third row and repeat the process. Right? When you can stop the process, you can stop the process when there is no non-zero element in that row. Even if there is some non-zero element, if there is no below row, you can stop. Right? We will do with examples. Okay, now we move on to second problem. Find the rank of, see, these are called elementary transformations. Find the rank of a matrix. Find the rank of a matrix 3 minus 8, 3 minus 8, 5, 2, 2 minus 5, 1, 4, minus 1, 2, 3, minus 2. See, rank of A will always be less than or equal to minimum of m comma n. So it has 3 rows and 4 columns. So rank of A will always be less than or equal to 3. It can be 1. See, as of now, I have said you rank is number of non-zero rows. In upcoming classes, why that rank is number of non-zero rows? What that rank tells? The rank tells it is 3. What that mean? That you will come to know in the upcoming class. It will be very, very interesting. That is what I said at the beginning of the class. In this class, it will be problem solving. Why? The rank is 3. What is the meaning of that? The rank is 2. What you are coming to say by that? The rank is 1. What you are coming to say by that? That we will come to know in the upcoming classes. In this class, purely based on how to find. That's it. I said in the beginning itself, right? Okay. But I will surely let you know how what it means. When we do basis and dimension, we'll come to know that. Now go to first row, first non-zero element. So first row, first non-zero element is 3. So you have to make below that everything has to be 0. So here 2 is there, minus 1 is there. So we have to make that element as 0. So what we will do? So we will make an operation. R2 is transformed to. So here we have 2, here we have 6. So what we'll do is we'll multiply 3 here. So 3 times R2 minus 2 times R1. Is this clear? So multiplying 3 here, multiplying 2 here, and then I'm subtracting. You have to make these two elements 0 with the help of this element only. Okay. Now R3. So here we have 1, here we have 3. So multiply what 3 here. So 3 times R3. And then we will add with R1 because already here we have minus 3. So already is plus 3 here. You just add. This is a procedure, right? You always make this operation. R2 is equal to some alpha times R2 minus some beta times R1. Some beta times R1. Okay. So when I make these two operations, these two elements will be 0, right? So this will be transformed to 3 minus 8 by 2. Now what is R2 is transforming to? R2 is 3 times R2. So 3 times R2. 2 minus 5, 1, 4. Minus 2 times R1. 3 minus 8, 5, 2. So this is 6 minus 15, 3, 12. 6 minus 16, 10, 4. So 6 minus 6 is 0. Minus 15 plus 16, which is plus 1, right? Minus 15 plus 16 is plus 1. 3 minus 10 is minus 7. 12 minus 4 is 8. Is it clear? 12 minus 4 is 8. Now we'll move on to R3. So R3 is transformed to 3 times R3. R3 is minus 1, 2, 3 minus 2 plus R1. So 3 minus 8, 5, 2. So this is minus 3, 6, 9, minus 6 plus 3, comma, minus 8, comma, 5, comma, 2. So minus 3 plus 3 is 0. 6 plus 8 is minus 2. 9 plus 5 is 14. Minus 6 plus 2 is minus 4. So we are done with first step, right? First row, first non-zero element. Below that everything is 0. So we are done with first step. Now go to second step. Second row, first non-zero element is 1. So below that everything has to be 0. So you have to make minus 2 0 with the help of this circled element only. So we will make an operation. R3 is transformed to R3 plus 2 times R2. Is it clear? This is, I'm multiplying 2 here. Already it is minus 2. Add. This is R1. This is R2. This is R3. I'm making only row transformations. This is called elementary row transformations. So after doing this operation, this will be 3 minus 8, 5, 2, 0, 1, minus 7, 8. R3 plus 2 times R2. So it will be 0, right? Minus 2 plus 2 is 0. 14 plus 2 times minus 7. So 14 plus 14 is 0. R3 plus 2 times R2. So minus 4 plus 12. Minus 4 plus 12 is 8. Is it clear? Is it clear? Yes. Now we can see this is in row echelon form, right? First row, first non-zero element. Below that everything is 0. Good. Second row, first non-zero element. Below that everything is 0. Third row, first non-zero element is 8. But below there is nothing. You can stop. First row, first non-zero element, below element is 0. Second row, first non-zero element is 1, below that everything is 0. In third row, the first non-zero element is 8. Below that everything has to be 0, but here there is no below element. So we can stop the process. This is in row echelon form. See, you should not make R3 minus R2. This will become 0, sir. This will become 0, but this will become non-zero when you do that. So this is in row echelon form. It has 3 non-zero rows, right? All three are non-zero rows only, right? Non-zero row, non-zero row. This is also non-zero row because 8, it has 0, 0, 0, 8. It has 0, 0, 0, 8. Last value is 12. Minus 4. Minus 4. Uh, minus 4. Yes, yes. Minus 4 plus 16. 12. Right? But rank will not change. So it has 3 non-zero rows. So the rank of A is 3. Rank of A is 3. Is it clear? See, very easy to find rank. Very easy to find rank. You just make the matrix to row echelon form and find the number of non-zero. I'm giving you 8 exercise problem. 1, 2, 3, 4, 5, 6, 7, 8. So all these 8 problem you are going to take as exercise, right? All are very easy problem. You have to reduce the matrix to row echelon form and then you have to find the rank. I will do one problem. See, already you can do any problem. I will do one problem, right? I will take third problem. I will take third problem and I will do. See, for this problem, you can interchange R3 and R1. See, for this problem, you can interchange R3 and R1. So whenever you are finding rank, you can interchange also, right? So when you interchange, this will become your first row will be 3, 1, 0, 2. So first row, third row, I'm interchanging. You can do that. Interchanging rank will not affect, right? For this problem, you can do that. Uh, we can always interchange. I'll do one problem. So I'll take third problem. I will do this problem. Find the rank of a matrix. See, in the Google, you can also a website called, you just type rank of a matrix calculator. Go to Google and just type rank of a matrix calculator. There are many websites. Go to first website. They will ask the dimension of matrix. That is, they will ask number of rows and number of columns. For this matrix, number of rows is 1, 2, 3, 4. 4 rows, and columns is 1, 2, 3, 4. This is a 4 cross 4 matrix, right? 1, 2, 3, 4. Yes, it's a 4 cross 4 matrix. You just write 4 cross 4, and they will ask you to enter the matrix. So just write enter the matrix. It will show you detailed solution also. It will show you detailed solution also. That row echelon form reduction also, it will be shown in the calculator. So I'll take this problem 1, 2, 3, 4, 2, 1, 4, 5. 1, 2, 3, 4, 2, 1, 2, 1, 4, 5. 2, 1, 4, 5. 1, 5, 5, 7. 1, 5, 5, 7. 8, 1, 14, 17. So I'll take this problem and then I'll do this. So first row, first non-zero element is 1. Below that everything has to be 0. So we'll make these all element to be 0. So with the help of this element only, right? Okay. So what we have to do? R2 is transformed to R2 minus 2 times R1. R3 is transformed to R3 minus R1. R4 is transformed to R4 minus 8 times R1. Is this clear? When I make these three operations, my first row, first non-zero element, below that everything will be 0. Yes, so this matrix is equivalent to, see, you can always interchange rows, you can always interchange columns whenever you are finding rank of a matrix. So R2, so 1, 2, 3, 4 will remain as it is. R2 minus 2 times R1. So multiply 2 and then subtract. It will be 0. Multiply 2, it will be 4. So 1 minus 4 is minus 3. Multiply 2, it is 6. So 6 minus 4 is minus 2. Multiply 2, it will be 8. 5 minus 8 is minus 3. Right? When you get experience, you will get this. When you have a good practice, you can easily do in the mind itself. R3 minus R1. So 1 minus 1 is 0. 5 minus 2 is 3. 5 minus 3 is 2. 7 minus 4 is 3. Right? Multiply 8 and then subtract. It will be 0. Multiply 8, it is 16. 1 minus 16 is minus 15. Multiply 8 and then subtract. So 8 will be, 8 is a 24. 14 minus 24 minus 10. Multiply 8, it is 32. 17 minus 15, sorry, 17 minus 32, it is minus 15. Right, now first step is completed. First row, first non-zero element, below that everything is 0. Now go to second row, first non-zero element, which is minus 3. Below that everything has to be 0. So we have to make this as 0, this as 0. So what we have to do? So we have to make these two 0, therefore this element only. So R3 is transformed to R3 plus R2. I'm just adding these two, this will become 0. R4 is transformed to R4 minus 5 times R2. Is it clear? You already have minus 15 here. So we multiply 5, it will become minus 15. So minus 15 minus 15. So subtract will become 0. So this operation is now reduced to, matrix is now reduced to 1, 2, 3, 4. So 0, minus 3, minus 2, minus 3. Yes, so this is 0, R3 plus R2. See, I am making this as 0. In that process, other turning out to be 0. Right? My process is making this as 0. So I'm adding these two. In that process, this also turns out to be 0. That is not my fault. Right? Okay. So 0, 0, 0. Yes or no? 3 minus 3 is 0. 2 minus 0, 0. Now, you multiply 5 and then subtract. So it will be minus 15. You multiply 5, it is minus 10. Minus 10 plus 10 is 0. You multiply 5, 0. That's it, right? See, just 2 minutes you can do this problem and you can get 10 marks. You can just get 10 marks in just 3 minutes. This in row echelon form, right? First row, first non-zero element, below that everything is zero. Second row, first non-zero element, below that everything is zero. Third row, first there is no non-zero element. Go to fourth row, there is no non-zero element. So this is in row echelon form. This matrix in row, this matrix is in row echelon form. How many non-zero rows? It has two non-zero rows. It has two non-zero rows. So the rank of this matrix is 2. I'm repeating. I'm telling. I'm doing this class in problem solving point of view. You'll come to know why what rank is 2 means, what it means. That will come to know in the upcoming classes. You can do these 8 problems, right? Can you give me the confidence in comment section that you can do these 8 problems? Or if you want me to do one more problem, I have did third problem. See, for this problem, you just interchange R3 and R1. For fourth problem, you just interchange R3 and R1. For fourth problem, you start with R1 is interchanged to R3. See, I'll give you one very important tip. Whenever you are finding rank of a matrix, you always make sure that the first row, first non-zero element is non-zero. You always make sure that the first row, first non-zero, first row, first element is non-zero. You always make sure first row, first element is always non-zero. Here you can see first row, first element is 0. You always make as non-zero. It will be easy for you to, and it will be convenient for you to do the problem. So what I'm doing is I'm interchanging R3 and R1. If I do that, first row, first element will be non-zero. So this matrix will be reduced to 3102, 3102. R2 will remain as it is, 0011, 0011. R1 is now moving to R3, 001 minus 3 minus 1. R4 will remain as it is, 1 minus 2 0. So you always make sure that your first row, first element is always non-zero. It will be easy for you to do the problem. It will be easy for you to do the problem. You can always interchange rows. You can always interchange columns also. You can interchange columns also. For example, you can interchange C1 and C2. So you can interchange C1 and C2. In that way also you can do. In that way also you can do, right? Okay. Now after this you can do this, right? See, you can directly go to this step. First row, first non-zero element, below that everything is 0. Already this is 0. So you just make R3 is transformed to 3 times R3 minus R1. Because already these two are 0, right? So our step is smaller now. This is equivalent to 3102, 0011, 01 minus 3 minus 1. So multiply 3 here and then subtract. Multiply 3 here and then subtract. So 3 minus 1 is 2. Multiply 3 here and then subtract. So minus 6. Multiply 3 here and then subtract. So it is minus 2. So first row, first non-zero element. First row, first non-zero element. Below that everything is 0. Now go to second row. Second row, first non-zero element is 1. So below that everything has to be 0. Below that everything has to be 0, right? So we will make this as 0. Second row, first non-zero element. This is 0. So R3 is transformed to R3 plus 3 times R2. I'm multiplying 3 and then adding. R4 is transformed to R4 plus 6 times R2. So when I make this operation, 3102, 0011, 0011, R3 plus R2. Sorry, R3 plus 3 times R2. This is 01, right? 01 minus 3 plus 3, 0. You multiply 3 and then add. So it is minus 1 plus 3. Minus 1 plus 3 is 2. Now here R, you multiply 6 here and then add. Right? I'm multiplying 6 and then adding. I'm multiplying 6 and then adding. I'm multiplying 6 and then adding. So minus 2 plus 6 is 4, right? Now you can see first row, first non-zero element, below that everything is 0. Second row, first non-zero element, below that everything is 0. Now third row, first non-zero element is 1, right? Below that everything has to be 0. So we have to make 2 as 0. Is it clear? First row, first non-zero element, below that everything is 0. Second row, first non-zero element is 1. Non-zero means other than 0, 1. Below that everything is 0. Now go to third row. Third row, first non-zero element is 1. We have to make this 2 as 0. So what we will do? So we will do R2 is equal to, sorry, R4 is equal to, we have to make this as 0 now, right? We have to make this as 0. We have to make this as 0 now. So R4 minus 2 times R3. This is equivalent to 3102 0011 0102. Yes, now we'll multiply 2 and then subtract, right? We have to multiply 2 and then we have to subtract 0000, right? Yes or no? Multiply 2 and then subtract, multiply 2 and then subtract. Now this is in row echelon form, right? First row, first non-zero element, below that everything is 0. Second row, first non-zero element, below that everything is 0. Third row, first non-zero element is 1, below that everything is 0. Now go to fourth row. Fourth row, there is no 0. There is no non-zero element. So we can stop the process. Now what is this in row echelon form? This is in row echelon form. This is in row echelon form. So what is rank? Rank of this matrix is 3 because it has 3 non-zero rows, right? Because fourth row is 0 row. Other than that, it has 3 non-zero rows. Is it clear? You can do the remaining problems, right? So I have did third and fourth problem. Similarly, you can see here. You can see in this case, you can also it will be easy to, it will be convenient for you if you make R1 is and R2 are interchanged. If you do this, if you have 1 in the first element, it will be easy for you to for calculation. It is not mandatory, but if you have 1 in first row, first element, it will be easy for in calculation point of view. It is not mandatory, but if you do R1 and R2 interchange, uh, it will be easy for in calculation point of view. Suppose if interchange this 1 1 minus 8 1 5 7 2 1, then R2 is equal to R2 minus 5 R1, R3 is equal to R3 minus 2 R1, R4 is equal to R4 minus 3 R1. So these three element will be 0. Similarly, you take go to first row, first non-zero element, below that everything is 0. Go to second row, find first non-zero element, below that everything is 0. With the help of, you have to make that all elements 0 with the help of that element only, non-zero element in that row. Now go to third row, find the first non-zero element, below that everything has to be 0. You have to make that element 0 with the help of this element only, non-zero element. Go to fourth row, go to fifth row, how many rows you have, repeat the process until you get the echelon form. Is the rank of a matrix is clear? So do these 8 problems. It is slightly time consuming when you have this kind of problem, right? Fifth problem, you can see, you have to, what is the operation you have to do in fifth problem. So we have 5 rows. We have 5 rows. Yes or no? It has 5 rows. So what you have to do? R2 minus 2 R1, R3 minus 3 R1, R3 minus R4 minus 3 R1, R5 minus 8 R1. So if you do this, all these will be 0. Now go to second row. Now we have to make these 3 elements 0. Time consuming. Go to fourth row. Go to third row and below that make everything 0. You find non-zero element in third row, below that everything is 0. So until you have to get the echelon form, you have to proceed. Slightly time consuming, but it is very easy. Just addition, subtraction and multiplication, right? Okay. Yes. So now I'll move on to consistency of non-homogeneous system of equations. consistency of non-homogeneous system of linear equation. See, we are going to find the solution of system of equation. That's it. We are going to find the solution of system of equations. 99% you will have three variables only. You know how to solve a system of equation in two variable, right? Whenever you have two variable, you can solve. In 10th standard, we will do elimination method, cross multiplication method, substitution method. That you will do, right? If you have a system of equation in three variable, how to solve? Okay, consider a non-homogeneous system. Non-homogeneous system means the output vector is non-zero. Consider 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 the non-homogeneous system Ax is equal to B and B is not equal to 0. Consider the non-homogeneous system and B is not equal to 0. That means your output vector is non-zero. That means your output vector is non-zero, right? Okay. Consider non-homogeneous system. Let us consider this equation, right? Let us take this equation a11x plus a12y uh, plus a13z is equal to b1. A21x plus a22y a23z is b2. A31x plus a32y plus a33z is equal to b3. See, we have a system of equation in three variable, right? This a11, a12, a13 are coefficients. This ai are real number and bi belongs to real number, not all zero. Because your b1, b2, b3 is your output vector, all not zero. That means it has to be non-zero. If it is non-zero only, we will have non-homogeneous system. Non-homogeneous means your output vector is non-zero vector. For example, you consider this equation. X plus 2y plus 3z is 4. X plus 3y plus 8z is 8. 4x plus 2y plus z is equal to 9. This is an example of this, right? Here you can see your a11, a12, a13. That is 1, 2, 3, 1, 3, 8, 4, 2, 1. Your output vector is 4, 8, 9, which is a non-zero vector. Zero vector means everything has to be zero. Non-zero means your output vector has to be non-zero. Even if you have 0, 0 here, it is non-zero only. Your output vector is 4, 0, 0, which is non-zero vector. So your output vector has to be non-zero. Then we will call the system as non-homogeneous system. If output vector all are zero, then we will call that as homogeneous system. First, we are considering only non-homogeneous. That is, your output vector B is not equal to 0. That is not a zero vector. So, how to solve the system of equation? So, consider Ax is equal to B. We have to write in this format. A is called the coefficient matrix. A is called the coefficient matrix. How to write A? You just write the coefficient of x, y, z. So, what we have here? A11, A12, A13. A21, A22, A23, A31, A32, A33, right? And x is the variable. What is a variable here? X, Y, Z. For example, if you consider here, what is your coefficient matrix? 1, 2, 3, 1, 3, 8, 4, 2, 1. Your unknown variables are x, y, z, and b is your output vector. So which is here is b1, b2, b3, b1, b2, b3. So your output vector is 4, 0, 0. Is this step is clear? So whenever you have a non-homogeneous system, you can always write ax equal to b. A is your coefficient matrix and x is the out variable, number of variables, that is what are the variables you have to find, and b is the output vector, which here is b1, b2, b3. Now form the augmented matrix. Form the form the augmented matrix. Form the augmented matrix. So you have to augment A and B. What is A? A is your quotient matrix. What is B? B is the output vector. So your augmented matrix will be A11, A12, A13, A21, A22, A23, A31, A32, A33, B1, B2, B3. Is it clear? I'm just augmenting A and B. This is the first step you have to do. Now, what about, see, we need to solve the system, right? Solving means we need to find the solution. Solving means we need to find the solution. You need to find x, y, z. If I substitute x, y, z in all the equations, it has to satisfy this output. If I substitute x, y, z here, you have to get 4. If I substitute the same x, y, z here, you have to get 0. If I substitute the same x, y, z here, you have to get 0. That is the solution, right? Now, what about the types of solutions? What about the types of solutions? When you will have unique solution, when you will have infinitely many solution, when you will have no solution, you have to find xyz. That is our aim. When you will get only one xyz, there is only one xyz that satisfies this equation simultaneously, all three. There are infinitely many xyz. All that xyz will satisfy this. There is no xyz that satisfies all three equations simultaneously. So three cases arise, right? Okay. Now case 1. Case 1. Case 1. If reduce reduce the reduce the augmented matrix to row echelon form. Reduce the augmented matrix to row echelon form. What is your augmented matrix? You have an augmented matrix, right? You reduce this matrix to row echelon form. You know how to reduce the matrix to row echelon form, right? You know how to reduce the matrix to row echelon form. Now, if rank of A is same as rank of A comma B and equal to 3, which is equal to total number of variables, right? Let us forget 3 here. Let us not write 3 here. If rank of A and rank of A comma B is equal to total number of variables, see, usually in 99% in exam point of view, we will have only 3 variables. So that means I'm putting in bracket if both are equal to 3. Here also I've written only 3 variables, right? 99% you have 3 variables. If rank of A and rank of A comma B are equal to total number of variables, if you have 3 variables, if rank of A and rank of A comma B both are equal to 3, the system is consistent. The system is consistent and has unique solution and has unique solution, right? How to see? You have to reduce this in row echelon form. After reducing this to row echelon form, you just place an and here. This is a A matrix, right? This is an A matrix. When you combine, it is A comma B. After reducing to a row echelon form, you just place and here. This is a 3 cross 3 matrix. For this matrix, you find the rank. Already it is in row echelon form. You just find number of non-zero rows, right? And see overall the rank. That is, you find rank. This is A. This is A matrix. You find rank for this matrix alone. Already it is in row echelon form. You just find number of non-zero rows. Now you combine fully and see find number of non-zero rows. If both are equal to 3, then this system is consistent and has unique solution. What is that unique solution? to find that unique solution, to find that unique solution, write the write the reduced write the reduced echelon matrix to Ax is equal to B form and solve by backward substitution. Right? When I do problem, you will get 100% clarity. As of now, you write the theory part. If you understand this single page, then you can do any problem. There will be one question surely from this point. Now, case 2. Again, reduce the augmented matrix. Reduce the augmented matrix to row echelon form. Right? If rank of A and rank of A comma B both are equal to 2, right? That is less than total number of variables, right? See, we are talking only for 3 variables. If you have 4 variables and if both the rank are equal to 3, suppose, see, you are reducing the row echelon form. You are comparing rank of A and rank of A comma B. If both are equal to 3, then it has unique solution. How to find that solution? You write the reduced echelon matrix to Ax equal to B form and solve by backward substitution. That is not written here. That we will discuss in problem. Suppose find the rank for this and find the rank for entire thing. If both are equal to 2, which is less than number of variables, right? Both are equal also. Both are equal to 2 and less than number of variables. In this case, the system is consistent and has infinitely many solutions. And has infinitely many solutions. To find those infinitely solution, to find those solutions, we have infinitely many solutions, right? I'm going to find all that solution now. I'm going to find all that solution now. A minute. I'm going to find all that solution now. I'm going to find all that solution now. Here, there is a concept called number of free variables. That number of free variable is given by n minus rank of A. N is the total number of variable. Right? Number of free variable is formula is n minus rank of A. In this case, suppose if you have 3 variable, your n is 3 and you by your in this case your rank is 2, so you have one free variable. Yes or no? So if your rank is, what is your number of free variable formula? N minus rank of A. N is total number of variable. Suppose if your rank both are equal to 2, then your rank is 2. In this case, you have one free variable. So assume, as you can, that means one variable is free. You can assume one variable to be anything in your own. I'm assuming z to be equal to k. Assume z is equal to k and write z is equal to k and write reduced echelon matrix in Ax equal to B form and solve for x1 xy using backward substitution. I'll write BS using backward substitution, right? Yes. Now we'll move on to case 3. So what is case 3? After reducing the augmented matrix, after reducing the augmented matrix, if to row echelon form, after reducing the matrix to row echelon form, if rank of A comma B both are equal to 1. See, I'm using only for three variable. I'm explaining only for three variable, right? You can generalize for n variable also. If both are equal total number of variables, unique solution. If both are equal and less than total number of variables, in this case also the system is consistent. The system is consistent and has infinitely many solution, right? Again, to find those solution, to find those solutions, number of free variable, number of free variable is n minus rank of A is the formula. So here you have two free variable, right? Because n is total number of variables, which is we are discussing only for three. So rank is 1 by this case. So you have two free variable. That means you can assume two variable in your own. Let us take z to be k1 or y to be k1. You can take any two variable, right? Let us take x to be k1, y to be k2, and solve for z, and solve for z. Here you can see I have solved for xy by assuming z is equal to k. Assume z is equal to k and write this, or you can write the same thing. Assume x is equal to k1, y is equal to k2, and write reduced echelon form, and write reduced reduced echelon form to ax equal to b, and solve for z by backward substitution. So you can also assume y to be k1, z is equal to k2, and solve for x also. You can assume any two variable in your one. K1, k2 are real number, right? Here k is any real number. Here k1, k2 are any real number. Now case 4. After reducing to row echelon form, after after reducing to after reducing the augmented matrix to row echelon form, after reducing after reducing the augmented matrix to row echelon form, if rank of A and rank of A comma B are not equal, in first case both are equal to total number of variables. In second case both are equal to 2, both are equal and equal to 2, which is less than total number of variables. Both are equal and equal to 1, again which is less than number of variables, strictly less than total number of variables. If rank of A and not equal, the system is inconsistent. The system is inconsistent and has no solution. That's it. So if you understand this single page, you can do any problem. Easily you can get 10, 12 to 15 marks. You will get one question from this. You will get surely one question from this topic, right? I will do many problems, right? I'll be doing some 7 to 8 problems based on all cases, right? Is this clear? Is this clear? Problem 1. See, consistency means unique or infinite or no solution, right? Test the consistency and solve the following equations. So we'll start with the first problem. I'm not going to do many problems, right? I'm just going to do one or two problems. I'm going to give you many exercise problems for you. Okay. X minus y plus 2z is equal to 2. 2x plus y plus 4z is 7. 4x minus y plus z is equal to 4. Yes, we don't know whether the system has unique solution. If it is unique, what is the solution? We don't know. We don't know whether this system has infinitely many solution. We don't know that. We don't know whether this has no solution. That also we don't know. First, we need to test the consistency and solve the following equation if you can. Okay, solution. So first you write Ax equal to B. But first we have to identify whether it is homogeneous or non-homogeneous. It is non-homogeneous because our output vector is a non-zero vector. 274, it is non-zero. All 0 only, it is homogeneous. Right? Okay. So what is A here? A is 1 minus 1, 2, 2, 1, 4, 4 minus 1, 1. How many variables? X, Y, Z are the variables. What is the output vector? 2, comma 7, comma 4. 2 comma 7 comma 4. Okay. Now form the augmented matrix. The augmented matrix is you have to combine A and B. So 1 minus 1 2, 2 1 4, 4 minus 1 1, 2 7 4. Now you have to reduce this. I think there is some internet issue, right? Is the video is clear? The video is clear, right? Okay. So we have to reduce this augmented matrix to row echelon form. After that only we can decide whether the type of solution. Okay, so we'll reduce to row echelon form. So first row, first non-zero element, below that everything has to be 0. So R2 is equal to R2 minus 2 times R1. R2 is equal to R2 minus 2 times buffering in between. I think now it will be correct, right? Okay. So R2 is equal to R2 minus 2 times R1. R3 is R3 minus 4 times R1. So this is equivalent to 1 minus 1 to 2. Now you have to multiply 2 and then subtract. It will be 0. You have to multiply 2 and then subtract. So 1, you have to multiply 2. So it is minus 2. So 1 plus 2 will be 3. You have to multiply 2 and then subtract. You have to multiply 2 and then subtract. 7 minus 4 is 3. You have to multiply 4 and then subtract. You have to multiply 4. So minus 1 plus 4. Minus 1 plus 4 is plus 3. You have to multiply 4 and then 1 minus 8 is minus 7. You have to multiply 4 and then you have to subtract. Right? Now you have to make this element as 0. So R3 is R3 minus R2. So second row, first non-zero element, below that everything has to be 0. Now this is equivalent to 1 minus 1, 1 minus 1, 2, 2, 0, 3, 0, 3. Now you just have to subtract 0 minus 0, 1 minus 1, 2, 2, 1, 4, 4 minus 1, 1. Multiply 2 and then subtract. You multiply 2, 1 plus 2 is 3. You multiply 2 and then subtract. You multiply 2, 7 minus 4 is 3. You multiply 4, so it will be minus 1 plus 4 is plus 3. Multiply 4, 1 minus 8 is minus 7. You multiply 4, I think this is wrong, right? You multiply 4, so it will be 8. 4 minus 8 is this minus 4. Sir, no? You multiply 4, so it will be 8. So 4 minus 8 is minus 4. Now subtract. So this will be 0, 0. Minus 7 minus 0 is minus 7. Minus 4 minus 3 is minus 7. Now this is in row echelon form, right? This is in row echelon form. This is in row echelon form. This is in row echelon form. Yes or no? So first row, first non-zero element. Below that everything is 0. Second row, first non-zero element. Below that everything is 0. Third row, first non-zero element is minus 7. Below there is no anything. Now you have to find rank of A. Now what is rank of A? Just place finger here and here. 1 non-zero row, 2 non-zero row, 3 non-zero row. So rank of A is 3. Now what is rank of A comma B? That is also equal to 3, right? Now you see overall 1 non-zero row, 2 non-zero row, 3 non-zero row. You consider this A, 1 row, 2 non-zero row, 3 non-zero row. So it falls under case 1, right? It falls under case 1. Rank of A and rank of A comma B both are equal to 3, which is equal to total number of variables. Is equal to total number of variables. That means what? The system is consistent. The system is consistent and has unique solution. And has unique solution. There is only one XYZ that you can find that satisfying these three equations simultaneously. To find that solution, what I've done here? To find that solution, to find the unique solution, write the reduced echelon matrix to Ax equal to B form. So write this matrix, write reduced echelon matrix to Ax is equal to B format. So in this reduced echelon matrix, this is your A. 1 minus 1 2 0 3 0 0 0 minus 7, and your variables are x y z, and your B is this, right? 2 3 minus 7. Write the reduced echelon matrix to X equal to B and solve by backward substitution. Just form the equation here. So x minus y plus 2z is 2, right? See, just a matrix multiplication. This row, this column. So x minus y plus 2z is equal to 2. Two matrices are equal means corresponding elements are same. And here you will have 0x, 0x plus 0y. Here you can see 3y is 3. Here you will have minus 7z is minus 7. Yes or no? See, this into this. X minus y plus 2z is 2. 0x plus 3y plus 0 is 0, it is 3. 0x plus 0y minus 7 is, that is minus 7. Solve by backward means you start from third equation. So from this, you call this as 1, you call this as 2, you call this as 3. So from 3, what is your z? Z is 1. From 2, what is your y? Y is 1. From 1, what is your x? X is 2 plus y minus 2z, right? X is 2 plus y minus 2z. And we know y is 1, z is 1. So this will be 1 again. So x is equal to 1, y is equal to 1, z is equal to 1 is the solution. You can check by substituting here. X is equal to 1, y is equal to 1, z is equal to 1. 1 minus 1 is 0, 2 into 1 is 2. 2 plus 1 plus 4 is 7, good. 4 minus 1 is 3, 3 plus 1 is 4. So therefore our solution is correct. So therefore the solution is x is equal to 1, y is equal to 1, z is equal to 1 is the solution for that. Is it clear? If rank of A and rank of A comma B both are equal to 3, and if both are equal total number of variables, in this case you will have unique solution. So in this case the system is consistent and has unique solution. Can you move on to the next problem? So solve 2x plus 3y plus 3z is 5, x minus 2y plus z is minus 4, dx minus y minus 2z is 3. See, we don't know whether this has unique, whether this has infinite, whether it has no solution, right? So first what we'll do is, first this is a non-homogeneous system. This is a non-homogeneous system. Ax equal to b and this b is not equal to 0. So write the quotient matrix 2, 3, 3, 1 minus 1, 1, 3 minus 1, minus 2, and your variables are x, y, z. Your output vector is 5 comma minus 4 comma 3. So form the augmented matrix. So the augmented matrix is given by 2, 3, 3, 5, 1 minus 1, 1 minus 4, 3 minus 1, minus 2, 3. This is your augmented matrix, right? Reduce the augmented matrix to row echelon form. So first we will reduce this to row echelon form. So R2 is transformed to R2, 2 times R2 minus R1. R3 is transformed to 2 times R3 minus 3 times R1. So this is equivalent to 2, 3, 3, 5. Multiply 2 and then subtract. Multiply 2, multiply 2, it will be minus 2. Minus 2 minus 3 is minus 5. Multiply 2 and then subtract. So 2 minus 3 is minus 1. Multiply 2 and then subtract. Minus 4, sorry, multiply 2, minus 8, minus 5, minus 13. Multiply 2 here, multiply 3 here and then subtract. You multiply 2 here, this will become minus 2. You multiply 3 here, this will become 9. So and then subtract. Minus 2 minus 9 is minus 11. Is it clear? You multiply 2, so it will be minus 2 minus 9. You multiply 2 here, this will become minus 4. You multiply 3, this will become 9. So minus 4 minus 9 is minus 13. You multiply 2, it will become 6. You multiply 3, it will become 15. and then subtract. So 6 minus 15. 6 minus 15 is minus 9. Right? Now the first step is over, right? First row, first non-zero element. Second row is okay, okay, okay. Sorry. That is why you're getting 1 minus 2. Okay. Thank you, thank you. So that means this element will change now, I think. So multiply 2, multiply 2. So minus 4, minus 3. This will be minus 7, right? 2, 3, 3, 5. 1 minus 2, 1 minus 4. 1 minus 2, 1 minus 4. 3 minus 1, minus 2, 3. So multiply 2 and then subtract. Multiply 2. Minus 4, minus 3 is minus 7. 2 minus 3 is minus 1. Minus 8 minus 5 is minus 13. Multiply 2 minus 2 minus 2 minus 9 is minus 11. Multiply 2 minus 4 minus 4 minus 9 is minus 13. 6 6 minus 15 is minus 9. Yes, this is minus 7. Now we have to make this as 0. So R3 is transformed to 7 times R3 minus 11 times R2. Is it clear? If multiply 7, it will be 77. If multiply 11 here, it will be 77. So after this will be equivalent to 2, 3, 3, 5, 0, minus 7, minus 1, minus 13. So 7 times R3, 11 times R2. This will be 0 because this is minus 77 plus 77. Now here 7 times R3 minus 11 times R2. So what this will be? So this is minus 80, minus 91, minus 91 plus 11. So this will be minus 80. Now here 7 times R3 minus 11 times R2. So minus 63 plus 11 into 13. So 11 into 30 is 13 is what? 130, 143, right? 13 tens are 130. 143 minus 60 is what? 43 plus 37 is 80. Is it clear? Now after this operation, you can see this in row echelon form. So this matrix is in row echelon form. And you can see what is rank of A, it is 3, and rank of A comma B is also equal to 3, and it is equal to total number of variables. Yes or no? Thus, you can see when you consider this matrix A, rank is 3, 3 non-zero rows. When you consider overall also, rank is 3. So therefore, rank of A and rank of A comma B both are equal to 3. The system is consistent. The system is consistent and has unique solution. To find that unique solution, reduce the write the reduced matrix to Ax equal to B form. 2, 3, 3, 0, minus 7, minus 1, 0, 0, minus 80, x, y, z, 5, minus 13, 8. So form an equation. So 2x plus 3y plus 3z is 5, minus 7y minus z is minus 13, minus 80z is 80. So you have to solve by backward substitution. From 3 you can find z. From 2 you can find y, and from 1 you can find x. So from 3 your z is -1, and from 2 -7 times y minus z is -13. So -7y is -13 minus 1. So your y is 2, right? This will be +1. So -1, your y is 2. And from 1, 2x plus 3 times y plus 3 times z is 5. So 2x is 5 minus 6 plus 3. So 5 plus 6, 5 plus 3 is 8. 8 minus 6 is 2. So our x is 1. So x is 1, y is 2, z is -1. X is 1, y is 2, z is -1. So you have a unique solution, and this is the unique solution. You can check it out. X is 1, y is 2, z is -1. So 2 plus 6, 2 plus 6 is 8. 8 minus 3 is 5. Yes, correct. 1 minus 4 is -3. -3 minus 1 is -4. Perfect. 3 minus 2 is 1. 1 plus 2 is 3. Yes. So therefore our solution is correct. Is it clear up to now? Now we'll move on to problem number 3. Three x plus y plus z is 2. X minus 3y plus 2z is 1. 7x minus y plus 4z is 5. So we don't know whether this has unique, whether this has infinite, or whether it has no solution. We don't know that. So first we will write, this is a non-homogeneous system, right? So first we will write this in Ax equal to b form, b not equal to 0. So what is your A? A is 3, 1, 1. 1 minus 3, 2. 7 minus 1, 4. And your x is xyz, and your b is 2, 1, 5. Now form the augmented matrix. Form the augmented matrix. So 3, 1, 1, 2. 1 minus 3, 2, 1. 7 minus 1, 4, 5. Now reduce the augmented matrix to row echelon form. Reduce the augmented matrix to row echelon form. So R2 is transformed to 3 times R2 minus R1, right? So we have to make these two elements as 0. So therefore, this will be R3 is, let us multiply 3 here. This will become 21. Let us multiply 7 here. Is it clear? So multiply 3 and then subtract. You multiply 3, this will be 21. You multiply 7, will be 21. So 21 minus 21 is 21 minus 21 is 0. 21 minus 21 is 0. So therefore, this is equivalent to 3, 1, 1, 2. Multiply 3 and then subtract. Multiply 3 minus 9 minus 9 minus 1 is minus 10. Multiply 3, 6. 6 minus 1 is 5. Multiply 3, 3. 3 minus 2 is 1. Multiply 3, multiply 7 and then subtract. To multiply 3, this will be minus 3. Minus 3 minus 7 is minus 10. To multiply 3, 12. 12 minus 7 is plus 5. To multiply 3, this will be 15. To multiply 2, it will be 14. So 15 minus 14 is plus 1. Now we have to make this element 0. So R3 is transformed to R3 minus R2, right? Because first row, first non-zero element, below that everything is 0. So first step is clear. Now for second step, second row, first non-zero element, below that everything has to be 0. Now this is 3, 1, 1, 2, 0, minus 10, 5, 1. This turns out to be 0, 0, 0, 0. which is in row echelon form, right? The above matrix, the above matrix is in row echelon form. The above matrix is in row echelon form. And what is rank of A? Rank of A and rank of A comma B both are equal to 2 in this case, right? So you can see rank of A is 2, and you see overall rank of A comma B is also 2 here, which is less than total number of variables, which is less than total number of variables. So that means the system is consistent. System is consistent and has infinitely many solutions. And has infinitely many solutions. And number of free variable. Number of free variable is n minus rank of A. So you have one free variable. So assume z is equal to k. Assume z is equal to k. You can see here I have written the procedure also. And we are in case 2, right? This falls in case 2. The system is to find the solution. Number of free variable is always 1 here. Assume z is equal to k and write the reduced echelon matrix in Ax equal to b and solve for xy by backward substitution. Now write the reduced echelon matrix to Ax equal to b. So this is a reduced echelon matrix. 3 1 1 0 minus 10 5 0 0 0. Clear? Write the reduced echelon matrix. Write reduced right reduced echelon reduced echelon matrix in Ax equal to b format. Now you form an equation. So 3x plus y plus z is 2 minus 10y plus 5z is 1. See, you have only two equations now, right? The previous case you have three equations. Here you have only two equations and we know z is k, right? And since let us call this as equation 1 and equation 2, your solution will be everything in terms of k. 1 is 2. So from 2, so minus 10y plus 5k is 1 because k is z is k. So minus 10y is 1 minus 5k. So your y is 5k minus 1 by 10. Your x will be in terms of k. And from 1, 3x plus y plus z is 2. So 3x is 2 minus y minus z. 2 minus y is 5k minus 1 by 10 minus z. So which is 20 minus 5k plus 1 minus k by 10. So 21 minus 6k by 10 is 2x. So x is 21 minus 6k by 20. 3x plus y plus z is 2. So minus 10y plus 5z is 1. So minus 10y is 1 minus 5k. So y is 5k minus 1 by 10. So 3x is 2 minus y minus z. So y is 5k minus 1 by 10. So 20 minus 5k plus 1 minus k by 10. So 21 minus 6k by 10. Yes, this is your solution. So if you take 3 outside, uh, 3 by 20. So 3 by 20, I'll just check the solution. Um, Is there any mistake I have made? Z is k, y is 5k minus 1 by 10. So 3x plus y plus z is 2. So, okay, this is 3x. Sorry. This is 3x. This is 30. So if you take 3 outside here, you will have what? Okay. Here also this is 10k. So this is minus 15k. Minus 5k plus 1 minus 10k divided by 10. So minus 15k. So yes, this is 3x. So y is 5k minus 1 by 10 and z is k. So 20 minus 5k. Y is 5k minus 1 by 10. Z is k. So 20 minus 5k plus 1 minus 10k by 10. So 21 minus 15k by 10. This is 3x. So x is 7 minus 5k by 30. So which is 1 by 10, 7 minus 5k. So this is your solution. So therefore the solution is x is 1 by 10, 7 minus 5k. Y is 1 by 10, 5k minus 1. Z is k and this k belongs to real number. See, if you vary k, all these will be solution. If you vary k, all this will be solution. For example, let us take k to be equal to 1. If k is equal to 1, what you will have? If k is equal to 1, so your x will be what? Your x will be 7 minus 5, 2 by 10. Yes or no? If k is, okay, let us take k to be, um, k is 1, 2 by 10. So it will be 1 by 5. Y will be, if k is 1, this is 4 by 10. 4 by 10 is 2 by 5. And your z is 1. Suppose if I take this, see whether this satisfies or not. 3x plus y plus z. So 3x plus y plus z. So which is 5 by 5 plus 1. Yes, you can see this is 2. So it satisfies. Yes or no? And similarly, if you substitute here x minus 3y. So 1 by 5 minus 6 by 5. 1 by 5 minus 6 by 5 minus 1. Minus 1 plus 2. Yes, this is a solution. So if you vary k, you will get infinitely many solution. If k is 1, you can check it in exam point of view. You take k to be equal to 1. If you take k to be equal to 1, you will get x, y, z to be equal to 1 by 5, 2 by 5, 1. So therefore this is a solution, right? So therefore this falls under case 2. So if it falls under case 2, this is the pattern. Now we'll move on to next problem. Yes, and move on to problem 4. So solve. Okay, so we don't know whether it falls under case 1, case 2, or case 3, or case 4. So first we need to reduce the matrix to row echelon form. Then only we can do, right? Yes. Okay. So first we'll form the augmented matrix, right? I'll write this directly. So 4 minus 2, 6, 8, 1, 1, minus 3, minus 1, 15, minus 3, 9, 21. See, you can see in this third row, 3 is common, and in fourth row, sorry, first row, 2 is common, right? So what I'm doing is, I'm just dividing by 2. So 2 minus 1, 3, 4, 1, 1, minus 3, minus 1, 5 minus 1, 3, 7. You can do this, right? That is, I'm dividing R1 by R1 by 2, R3 by R3 by 3. So that numbers will be simple. Now you reduce to row echelon form. So R2 is transformed to R2 is transformed to R2. See, if you have 1 year, it will be easy for you to calculate, right? Okay, let us transform R1 and R2. It is not mandatory. 1 1 minus 3 minus 1, 2 minus 1 3 4, 5 minus 1 3 7. It is not mandatory, right? Okay. Now R2 is transformed to R2 minus 2 R1. R3 is transformed to R3 minus 5 R1. So this is 1 1 minus 3 minus 1. So multiply 2 and then subtract. You multiply 2, 1 minus 2 is minus 3. You multiply 2, 3 minus 6 is minus 9. 3 plus 6 is plus 9, right? So you multiply 4, 4 minus 4 plus 2, 3 plus 6. Multiply 5 and then subtract. You multiply 5, minus 1 minus 5 is minus 6. You multiply 5, 3 plus 15 is 21. 3 plus 15 is 18, sorry. You multiply minus 5, so 7 plus 5 is 12. Now R3 is transformed to R3 minus 2 times R2. So this is equivalent to 1 1 1 1 minus 3 minus 1, 0 minus 3 9 6. So multiply 2 and then subtract. So everything will be 0. This is in row echelon form. This is in row echelon form. The rank of A and the rank of A comma B both are equal to 2, right? Yes or no? Rank of A and the rank of A comma B both are equal to 2. That means the system is consistent System is consistent and has infinitely many solutions and the number of free variables n minus rank of A, total number of variables minus rank. So you have one free variable. Assume z is equal to k. Now write the reduced matrix to Ax equal to B form. 1 1 minus 3 0 minus 3 9 0 0 0 x y z minus 1 6 0. So we have x plus y minus 3z is minus 1 minus 3y plus 9z is 6. So we have only two equations. So put z is equal to k from 2. From 2 minus 3y plus 9k is 6. So minus 3y is 6 minus 9k. So y is, you take minus 3 outside here. You will have 3k minus 2 by minus 3. So y is 3k minus 2. And from 1, x is minus 1 minus y plus 3z. Minus 1 minus y is 3k minus 2 plus 3k. So minus 1 minus 3k plus 2 plus 3k. These two will get cancelled. So getting x to be equal to 1. So it is independent of k. So x is 1, y is 3k minus 2 and z is k. This will be your solution. Solution is x is 1, y is 3k minus 2, z is k. This k belongs to any real number. For example, you take k to be equal to 1. K to be equal to 1, 1 comma 1 comma 1, right? If k is 1, 3 minus 2 is 1. This will be a solution. Check it out. 4 minus 2 is 2, 2 plus 6 is 8, 1 plus 1 is 2, 2 minus 3 is minus 1, 15 minus 6 is 12, 12 plus 9 is 21. So therefore, if you vary k, you will get infinitely many solutions, right? We'll move on to problem 4 or problem 5. All yes. So we don't know whether this has unique, whether it has infinite, whether it has no solution, right? Okay. So first we'll form the augmented matrix. So which is 2 comma minus 1 comma 2, 6 comma minus 3 comma 3 comma 6, 4 comma minus 2 comma 4. So reduce the augmented matrix to row echelon form. So R2 is transformed to R2 minus 3 times R1. R3 is transformed to R3 minus 2 times R1. So when you do this operation, you will have 2 minus 1, 1, 2. Multiply 3 and then subtract. Multiply 3 and then subtract. Multiply 3 and subtract. Multiply 2 and then subtract. That's it. So in single stroke, it reduced to row echelon form. Now you can see rank of A and the rank of A comma B both are equal to 1. That means the system is consistent. The system is consistent and has infinitely many solutions. and the number of free variables in this case is 2, right? Number of free variables is equal to n minus rank of A. N is total number of variables minus rank of A. Rank of A is 1. So you have two free variable now. You can assume two things in your own. So assume y is equal to k1, z is equal to k2. This k1 and k2 belongs to any real number. Solve for x now. Now write reduced echelon form to ax is equal to b. So what is ax equal to b form? 2 minus 1 1 0 0 0 0 0 0 xyz 2 0 0. So you have only one equation now, right? In this case you will have only one equation, and we know z is k1, y is k2. So 2x is y minus z plus 2, and we know y is k1, z is k2 plus 2. So your x is k1 minus k2 plus 2 by 2. Therefore, the solution set is x is equal to k1 minus k2 plus 2 by 2, y is k1, z is k2. See, you have to vary k1, k2. For example, you take k1 to be 1, k2 to be equal to 1. If you vary k1, k2, you will get infinitely many solution. If k1 is equal to 1, k2 is equal to 1, this will be 1 minus 1 plus 2 by 2, 1 comma 1. So these two, so that means 1 comma 1 comma 1 is one of the solution. Can you check? 1 comma 1 comma 1. So 2 minus 1 is 1, 1 plus 1 is 2. 6 minus 3 is 3, 3 plus 3 is 6. 4 minus 2, 2 plus 2 is 4. Yes. So if you vary k1, k2, k2, if you vary k1 and k2, you will get infinitely many solutions. Right? Very simple. So we'll move on to problem 6. Solve solve x minus y plus z is minus 9, 2x minus 2y plus 2z is minus 18, px minus 3y plus 3z minus 27 is 0 plus 27. You just take this 27 to that side, right? Don't get confused. So again, this is a non-homogeneous system. So write the reduced, first we will form the augmented matrix A comma B. So 1 minus 1, 1 minus 9. So 2 minus 2, 2 minus 18. 3 minus 3, 3 minus 27. So we will make an operation R2 is transformed to R2 minus 2 R1. R3 is R3 minus 3 times R1. So this is transformed to 1 minus 1, 1 minus 9, 0, 0, 0, 0, 0, 0, 0, 0. Yes or no? So you can see by the single transformation, R2 and R3 turns out to be 0. So this is in row echelon form. This is in row echelon form. Rank of A comma B, both are equal to 1 and less than total number of variables. That means the system is consistent and has infinitely many solutions. Number of free variable is equal to n minus rank of A, total number of variables minus rank. So we have two free variables. So assume y is equal to k1, z is equal to k2, and solve for x. Write the reduced echelon matrix to Ax equal to B form. So you will have x minus y plus z is minus 9, and we know y is k1, z is k2. So x is minus 9 plus k1 minus k2. The solution set is x is equal to minus 9 plus k1 minus k2, y is k1, z is k2, and this k1 k2 belongs to any real number. So if you vary k1 k2, you will get different many solution. For example, you just put k1 to be 1, k2 to be equal to, let us put both to be equal to 1. Then your x will be minus 9, your y will be 1, z will be 1, right? Minus 9, 1, 1. Can you check this out? Minus 9 minus 9 plus 1 minus 1. So minus 9 minus 1 plus 1. Yes, it is minus 9. So 2 into minus 9 is minus 18. Minus 18 minus 2 plus 2 is minus 18. So 3 into minus 9, yes, perfect. So therefore, whenever your solution, if you vary k1 and k2, you will get infinitely many solution. All these k1, k2 will satisfy that equation, right? Yes. So last problem of today's class, problem 7. I think you are getting the pattern right. First two problem I have solved problem based on unique solution. The next two problem I have solved problem based on infinitely many solution with the rank of A and rank of A comma B both equal to 2. And next two problem is based on infinitely many solution again, but in that case rank of A and rank of A comma B both equal to 1. Now you come to know that this will be no solution problem. So problem 7, solve 2x 2x plus 2y plus z is 5, x minus y plus z is 1, 3x plus y plus 2z is 4. So let us write the augmented matrix, form the augmented matrix A comma B. So 2 2 1 5, 1 minus 1 1 1, 3 1 2 4. So R2 is transformed to 2 times R2 minus R1. R3 is transformed to 2 times R2 minus 3 times R1. So this is equivalent to 2 2 1 5. Multiply 2 and then subtract. Multiply 2 and then subtract. Minus 2 is minus 4. Multiply 2 and then subtract. Multiply 2, 2 minus 5 is minus 3. Multiply 2, multiply 3 and then subtract. You multiply 2, multiply 3. So 2 minus 6 is minus 4. Multiply 2, 4. 4 minus 3 is 1. You multiply 2, 8. If multiply 2 it will be 8. 8 minus 15 is minus 7. Sir, no? You multiply 2 it will be 8. 8 minus 15. Yes. Now R3 is transformed to R3 minus R2 because this is not in row echelon form, right? First row, first non-zero element, below that everything is 0. Second row, first non-zero element is minus 4. Below that everything has to be 0, but minus 4 is here, which is not 0. So when you make use of this operation 2 2 1 5 0 minus 4 1 minus 3, this will be 0 0 0 minus 7 plus 3 is minus 4. This is in row echelon form, right? This is in row echelon form. Now what about rank of A? Rank of A is 2, yes or no? Rank of A is 2, yes or no? Rank of A is 2 non-zero rows. But what is rank of A comma B? It is 3, right? When you see overall, this is non-zero row, non-zero row, non-zero row, 0, 0, 0, minus 4. So here, rank of A is not equal to rank of A comma B. The system is inconsistent. The system is inconsistent and has no solution. That's it. Right? So whenever rank of A and rank of A comma B they are not equal, the system is inconsistent and has no solution. Yes. So we'll stop here. In the next class, we will be continuing problems based on non-homogeneous or finding unknown. So for what value of unknown, this will have unique solution. For what value of unknown, this will have infinity menu solution. For what value of this k, this will have no solution. That kind of problem we will do in next class. And then we will also finish homogeneous system also. Right. So in this class, what we have did is we have started with rank of a matrix. Right. First, you have started with rank of a matrix. I have given you 8 exercise problem. Take a screenshot, of this, take a screenshot now. So practice this 8 problem. I have did 2 problems in class itself. So after that we have introduced homogeneous system of equations. This is the core thing. If you understand this single page, then you can do any problem. If you understand this single page is enough to do any problem. Reduce the augmented matrix to row echelon form based on rank of A and rank of A comma B. You have to decide whether it has unique, whether it has infinite, whether it has no solution. And to find type of solution, you have to find number of free variables. And based on number of free variable, make assumption and solve by backward substitution. If it is infinity many solution will be in terms of k. If it is one free variable, solution will be in terms of k. If it is two free variables, solution will be in terms of k1 and k2. If you vary k, you will get all infinitely many solutions. So in the next class, we will continue more problems based on finding unknowns. Right? Thank you. All the best.